Number 7, part A, is saying prove the identity tan theta plus 7 over tan squared theta minus 3 is identical to sine theta cos theta plus 7 cos squared theta over 1 minus 4 cos squared theta. Right? So to prove this identity, we are going to pick one side to work with, and in this case I'm going to pick the left hand side. And the reason why I'm doing that is because I know that I can expand tan theta to give me sine theta and cos theta, right? Which is what we have this side. We have sine theta and cos theta, right? So I'll be dealing with the left hand side. Now for the left hand side, I'm going to write sine theta over cos theta for tan theta, and this is plus plus 7, right, over sine squared theta over cos squared theta minus 3, right? And simplifying the numerator there, we know this is 7 over 1, so for the numerator I have sine theta over cos theta and plus 7 over 1, and the common denominator here is cos theta. So cos theta into cos theta, that's 1, so I get sine theta plus 7 cos theta, like that for the numerator. And for the denominator, I have sine squared theta over cos squared theta minus 3 over 1, right? Cos squared theta, so this will be sine squared theta minus 3 cos squared theta, right? So I have these two expressions to work with. Now rewriting these, I have sine theta plus 7 cos theta over cos theta being divided by sine squared theta minus 3 cos squared theta over cos squared theta, right? And we know we're going to invert this, so it will be sine theta plus 7 cos theta over cos theta times cos squared theta over sine squared theta minus 3 cos squared theta, like this, right? And this is going to give us cos squared theta sine theta plus 7 cos theta over cos theta sine squared theta minus 3 cos squared theta, like this. So we can see that we can cross out this cos theta to be left with cos theta sine theta plus 7 cos theta, right? Here we crossed out 1 cos theta because for us to get cos squared theta is cos theta times cos theta. So if we have this over a cos theta, we can cross this out to be left with cos theta. And now multiplying this bracket by cos theta, we get cos theta sine theta plus 7 cos squared theta over sine squared theta minus 3 cos squared theta, like that. And looking at the right hand side, I can see that for the denominator I have terms in cos squared theta, right? So that means I have to turn this into a term with cos squared theta, and I know that would be 1 minus cos squared theta. From this identity, we said sine squared theta plus cos squared theta is equals to 1. So making this the subject, I'll get sine squared theta equals 1 minus cos squared theta. So this will be cos theta sine theta plus 7 cos squared theta over 1 minus cos squared theta minus 3 cos squared theta, right? And this will come down to cos theta sine theta plus 7 cos squared theta over 1 minus 4 cos squared theta, like this. And then we can see that this is identical to the right hand side, right? Then you get your 3 marks for that, right? And part B is saying hence solve the equation that equals 5 over tan theta, right? So usually when we see hence, it means we are using information from the previous question or the answer from the previous question, right? And we can see that this is what we were given on the left hand side. Was it left? On the right hand side of part A, right? And we've just proven that this is identical to this. So in place of this, we know we can always write this, right? So we're told that this is equal to this, and we can see that for the right hand side it's 5 over tan theta, right? So it will be wise for us to use tan theta plus 7 over tan squared theta minus 3 in place of this. Tan theta plus 7 over tan squared theta minus 3. Tan squared theta minus 3, right? We know it's identical to that, is equal to 5 over tan theta, right? And cross multiplying, we get tan theta plus 7 equal to 5 tan squared theta minus 3, right? And this will be tan squared theta plus 7 tan theta equal to 5 tan squared theta minus 15, like that, right? And taking everything to the right hand side, we get 5 tan squared theta minus tan squared theta, so that will be 4 tan squared theta minus 7 tan theta minus 15 equals to 0, right? And with this now we can get a quadratic equation if we say let x be tan theta. So this will be 4x squared minus 7x minus 15 equals 0, like that. Now with this we say x equals to, using our quadratic formula, this will be 7 plus or minus root of 7 squared, 49 minus 4a, then our c minus 15 over 2a, which is 2 times 4, 8, right? And punching this in our calculators, we get x equals 3, or x equals minus 5 over 4, like this. But we know that x is standing in for tan theta, so this means that tan theta is equal to 3, or tan theta equals minus 5/4, right? And for this, we are going to try and use the cast system. And for the cast, it's like this. Right, and for the first quadrant, we're saying O, meaning tan, sine, and cos, they're all positive, and we pick the principal value to be our answer. And for the second quadrant, that's where we have only sine theta being positive, and for our answer will be 180 minus PV. For the third quadrant, it's 180 plus PV, and for the fourth, it's 360 minus PV, right? And I'm going to try and explain it further using this question as an example. So for us to use this system, first we ignore the signs. By signs, I mean the sign here, we know it's a positive and this is a negative, so we're ignoring that. So tan theta equals 3 and tan theta equals 5/4. We're doing that to get the principal values. So the principal values will be theta equal to the tan inverse of 3. We get the first principal value, and the second one will be this 5/4, right? So the first principal value will be 71.6 degrees, and the second one will be 51.3. But these are not our answers yet. We're still going to use the signs that we ignored earlier to figure out how to get answers from this, right? So first, for this, our tan theta was positive. So tan is positive in the first quadrant where we've all being positive, and in the third, right? So taking our answers, we know the first is PV. We're going to take our 71.6 as our first answer. And for the second answer, when tan is positive in the third quadrant, it's 180 plus PV, which is 71.6. And this gives us 251.6, right? This will be our second answer for this. Then for the next part where tan was negative, tan is negative in the second quadrant and the fourth. Since it's positive in the first and third, here and here, it's negative for this one and this one. And for the answer in the second quadrant, it's 180 minus our PV for that's 51.3, right? And this gives us 128.7. And for the other answer is 360 minus PV, which is 360 minus 51.3. We get 308.7, right? And these are our four answers. But before we declare them to be our final answers, we look at this, the range for theta. It's going from 0 to 180. So looking at these answers, we're only picking answers between 0 and 180. So that means our final answers will be 71.6 and 128.7, right? 71.6 degrees and 128.7, right? That's how we get our answers using the cast system. Right, and that will be it for number 7.